Let's take a look at, if we've been given the graph of a quadratic, how we can use key information from that graph to be able to determine what the equation of that quadratic must be. Now, with the quadratic that I've got here on my right, you can see that we've been given three key pieces of information. We've been given the two roots as well as the y-intercept. Now, if you've got the two roots and a third point, doesn't have to be the y-intercept, but a third point, we can actually use this information to determine what the exact quadratic of this graph must be. Now, what we're going to do here is we're going to use the factorized format of the graph, because we know the factorized format of y equals a, x minus p, x minus q. When we've got it in this factorized format like we've got here, the p and the q are essentially our roots here. And when we're putting it into this factorized format, we need to change the sign of our roots, hence the x minus p and the x minus q. So from this information, because we know what the x-intercepts are, we can automatically say that this is equal to y equals x plus 1, because that's the opposite sign of this root, and x minus 3, because that's the opposite sign of this root over here. So all we've now got to determine is what this a value actually is. Now, to determine that a value, we need a separate coordinate from the roots, because we've already used the roots to determine these two parts. Now, in this case, we've got the coordinate 0, 3, or the y-intercept. So we know that when x is equal to 0, y is equal to 3. So we can substitute this information in. So our y of 3 must equal our x of 0, so 0 plus 1 is 1, 0 take 3 is negative 3. And from here, we've only got a left in our equation, so we can solve for a. So simplifying this out, 1 times negative 3 is negative 3, so this will be negative 3a. So therefore, our a value is going to be 3 divided by negative 3, or negative 1. So by substituting our third point in, we've determined the value of a, so now we can state what the actual equation of the quadratic is. So therefore, our quadratic is y equals negative 1, or just negative, of x plus 1, x take 3. So that's how we find the equation of a quadratic if we know the two roots and a third point. But let's go through just another example of this. So in this example here of my quadratic, what I now know is what one of the roots here is, so it's negative 2. I've also got the y-intercept of 16, so I've got a point there that I can use. And I also know the axis of symmetry is equal to 1. Now in this question, what I can actually do is I can use the two roots still to be able to find the equation of this quadratic, except I've got one extra step. I've got to determine what this root here actually is. Now use the axis of symmetry to determine that. Because I know that there is a total of 3 units to get to the axis of symmetry here, there needs to be a total of 3 units just in here. Now if I do that, I'm essentially needing to add 3 onto my axis of symmetry to determine what this root here actually is. So 1 plus 3 will be 4. So it means that the other root of my quadratic here is 4. Now I've got the same information as I had before. I've got my two roots and a third point. So what I do now is I use this general format of y equals a, x minus p, x minus q, to be able to substitute my two roots in, changing the signs of my roots. So y equals a, the opposite sign of this will be x plus 2, the opposite sign of this will be x take 4. And now I need to determine what my a value would actually be. To determine my a value, I need to substitute another point, and I know the y-intercept here. So I know that when my x is equal to 0, my y is equal to 16. So I substitute these values in. So 16 will equal 0 plus 2 is 2, 0 take 4 is going to be negative 4, and I now solve for my a. So my 16 here will equal 2 times negative 4 is negative 8, so it'll be negative 8a. When I divide by negative 8, my a will equal negative 2. So now I've determined what my a value is, I can just state now what my equation of this quadratic actually is. So therefore, the equation is y equals -2, x plus 2 in brackets, and x take 4 in brackets. So in summary, if we know 2 roots of our quadratic and a third point of our quadratic, doesn't always have to be this y-intercept, just a third point, what I can do is I can represent my quadratic in this factorized format, where my p and my q are the roots of my quadratic, but when I put them in, I need to change the signs of them. Once I've got that, I now need to solve what the a value, that value in front, would actually be. To do that, I need to substitute my third point in and then solve for that a value. Once I've done that, I can then represent the final equation that represents the quadratic of this graph.